Okay, I wanted to apply some transformations to our graph, so I just wanted to review some of these transformations. This week, we're only going to focus on two. I'm going to focus on the A value, and I'm going to focus on the D value for both the sine and the cosine. So this is still very similar to what we did earlier in the year. Remember, the A value is still going to control. The A value is still going to control the vertical stretch and compression. All right, so let's recall that whenever that A value is greater than 1, right, it's going to be a vertical stretch. And then whenever that A value is less than 1, it's going to be a compression. So whenever that A value is less than 1, it's going to be a compression. Now, I'm assuming that these are positive, right? So I'll put absolute value so we know whatever the positive is. And then a reflection will be a negative, right? So reflection is going to be if ever your A value is just negative. If it's negative. All right, and then we'll get to the B value, which is the horizontal stretch and compression, and the C value, which just moves your graph left or right. We'll get to that next week. And then the other guy we're going to look at is the D value. And all this does is move the graph up and down. And I give you a little tip here. The way you can identify the D value is it's not in parentheses. Right? You're going to notice the C value is always inside of the parentheses. Okay, so for this first example, I want us to graph the function y is equal to 2 sine theta. So we're going to graph this the same way we've been graphing all year long. First thing I want to do is I want to graph the parent function out. All right, I want to graph my parent function out. So so we have to memorize the points to our parent function for the sine, right? So the sine, right, this is sine. So let's write it in there. This is the sine. Y is equal to the sine of theta in this case. So it's asking here, what's the sine of 0? Right? What's the sine of 0 here? Well, the sine of 0 is just 0, right? What's the sine of pi over 2? Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2, negative 1. And then sine of 2 pi, we go back to 0. So that's our parent function. So I'm going to go ahead and graph that. Notice how it's just a little pattern, 0, 1, 0, negative 1, 0. So that's what we're doing here. So 0, then at pi over 2, it's 1. We're going by halves here. Right? Sometimes we need to change these y-axis values depending on what values are given, right? So if that was like an 8, then I would probably want to go by 2s or something to fit 8 in there. So anyways, then at pi, I go back to 0. Let me zoom out so you guys can see the values. Then at 3 pi over 2, I go to negative 1. And then at 2 pi, back to 0. So then I get that same shape we graphed out at the beginning. So it's going to look something like that. Not perfect, but it looks pretty good. Now we're going to go ahead and apply the transformation. So recall that your transformation here, the 2, this is a vertical stretch, right? This is going to be a vertical stretch. So the height of the height is going to be twice as tall. So we can do this in 2 ways. During the school year, I just showed you guys that we can just double the heights of this, right? So first thing to notice is that your values at the x-axis, the x-intercepts, these are not going to change. These are 0, right? So any values at the midline are not going to be affected by the amplitude, right? The A value. So what's going to happen is what we should do is we should look at these highest points right here, these little peaks, and we're going to double those heights. So if this is a height of 1, I'm going to double it, and it's now going to become a height of 2. So now it becomes a height of 2, right? I doubled 1. Same thing here. We know that this height right here is a height of 1. I'm going to double it and get a height of 2. So now I have a height of 2. So the zeros don't move. And then I go ahead and just redraw my graph with my peaks now twice as tall. Okay, that's one way to do it. So another way to do it is the a value. The a value is really just multiplying the sine of theta, right? Whatever the sine of the angle is, we're just multiplying it by 2. So one trick is that we can actually just multiply this by the a value. So 0 times 2 is 0, 1 times 2, 2, 0 times 2, oops, 0, negative 1 times 2 is negative 2, and then 0 times 2 is 0. And if we were to plot these points, we would get the exact same answer. So let's do a different color, that way we can see it. So 0, 0, right, that's 0, 0, then pi over 2, 2, then pi, 0, then 3 pi over 2, negative 2, and then 2 pi, 0. And we get the exact same graph. So either way you want to do it. I'm going to be using the table because as problems get more and more complicated, the table is going to make our lives a lot easier. Okay, so before we look at another example, I wanted to go through some of the features of this new graph. So I'm going to ignore the original graph. Whoops, that's way too big. I'm going to ignore the original graph. Let's try it. So we're just looking at the new graph. All right, this is the graph I'm looking at, the one highlighted in pink. So I want to identify all the features of that. So let's start with the domain. Okay, the domain's never going to change. The domain's always going to just be all real numbers. My range is going to be what's the highest to the lowest? Well, it goes from negative 2 all the way to 2. Or in other words, we can also say negative 2, whoops, we had to use negative 2 all the way to 2. The amplitude. Well, the amplitude, you can do this in two ways. You can look at the graph and notice the distance from the midline to the highest point, or we could just look at the number in front. So my amplitude is going to just be 2. The period is still the same, right? It started at 0 and it ended at 2 pi. So it's still the same, 2 pi. X-intercepts, let's go ahead and just look at where they are. We have 0 is one, we have pi, there's another one, and then we have 2 pi as well. So we'll just label the x-intercepts for just one period. And if we wanted more periods, we would just say 0 plus pi times k. Y-intercepts, we have one at just 0, 0. And then intervals of increase and decrease. So remember with this one, it is increasing. It is increasing from here to here, and then from here to here. So on these two ends, let me highlight them really good so we can see them. So the highlights in red are my intervals of increase, right? That's where it's going up. So it is increasing from 0. It is increasing from 0 all the way to pi over 2. Okay, so that's this first piece, right? Here's 0 all the way to pi over 2. Then it's increasing from 3 pi over 2 all the way to 2 pi. Then it's increasing from 3 pi over 2 all the way to 2 pi. Okay, now we need to find out where is it decreasing. So it is decreasing. It is decreasing right here in the middle. Let's see, maybe I can change the color up. There you go, that's better. All right, so right in that middle. So we've got, we're decreasing from pi over 2 all the way to 3 pi over 2, right? So we've got pi over 2, and we are decreasing all the way until I hit 3 pi over 2. Okay, so in this example, we're going to graph the cosine of theta plus 2. So we're going to go ahead and start off with our parent function here. Parent function for cosine of 0 is 1. Cosine of pi over 2 is 0. Then the cosine of pi is going to be back to -1. Cosine of 3 pi over 2 is 0, and then back to 1. So when I graph this, so we're going to have a point at 0, and because we're going up 2, I'm going to just go by 1s. So I'm going to go by 1s. So at 0, we've got 1s. Remember, cosine is always just going to start at 1, whereas sine starts at 0. Then at pi over 2, we go to 0. Then at pi, we go to -1. Then at 3 pi over 2, we go back to 0. And then at 2 pi, we go to 1. Now we can go ahead and draw our shape out. So something like that. Doesn't have to look perfect, but should look something like that. So what we're going to do now is we are going to move this graph up 2, right? So my amplitude here is 1. There's nothing in front of the graph. Since I have a plus 2 that's not in parentheses, then that tells me that I'm going to move the graph up 2 units, right? So I'm translating 2 units up. So I'm taking every unit here, and I'm just going up to 1, 2. So now that point is going to move there. Let's go ahead and zoom in a little bit. This point is going up 1, 2. So it is going to end up right about there. This point is going to go up 2. Right? This point goes up 1, 2. Goes there. And then this point goes up 1, 2. It ends up right there. So I'm going to go ahead and draw that same shape graph, but just up 2 units. All right, and there we go. So let's just go over a few things before we finish graphing this. Remember that each graph has a midline going right through the center. So what happens when we add 2 is now this midline is going to go up 2 units as well. So up 1, 2. So if you notice that this midline is going right through those 0 points. And we can see that the amplitude, right, the distance from the midline to these points is still 1, right? My amplitude is 1. Here, my amplitude is still 1. All right, and then from the midline to the highest point is still 1. All right, so that's one way to do it. Another way to do it is we can also just take our y values and we can add 2 to them as well. And if you notice, we did the exact same thing with the amplitude, right? I multiplied all my y values by whatever the amplitude was in the last example. So that's why in this week's lesson, we're only focusing on what affects the y values. So now this is going to become 3, this becomes 2, this becomes 1, this is 2, this is 3. So now if I graph the points, if I graph this point 0, 3, right? So now I'm going to have a whole new set of points, pi over 2, 2. Here I have pi 1. Here I've got 3 pi over 2 and 2, and then 2 pi and 3. So if I graph all these points, they'll land in the exact same place, right? So 0, 3, so up 1, 2, 3, that's right there. Then pi over 2, up 2, that's right there. Then pi up 1, that's right there. Then 3 pi over 2, then up 2. That goes there, and then 2 pi up 3, 1, 2, 3. That's going to go there. So the points end up in the exact same place. So whichever strategy you want to use is up to you. Once these problems get a little bit more challenging, I'm going to start to use the table way. All right, just to make lives a little bit easier. But I will also show you how to do it the quicker way as well. So if you want to do that, you can do that.